Welcome to the eighth video. Welcome to the eighth video of graph theory. And this eighth video of graph theory is on minimum spanning tree again. Now using Prim's algorithm, and we'll solve question. So prior to this, in video number 6 and 7, we have discussed Kruskal algorithm question. And what is Kruskal algorithm? We have discussed the Kruskal algorithm also find minimum spanning tree and Prim's, as we have already discussed in fifth video, that minimum spanning tree can be found by two methods. One is using Kruskal's algorithm and one is using Prim's algorithm. And in today's eighth video, we'll discuss what is Prim's algorithm and we'll solve question. And again, I'm saying I always follow the reverse engineering. Reverse engineering means I first solve the question using algorithm, and then I discuss algorithm, because once you solve the question, you have a proper understanding how this algorithm is working. Fine. And at that moment, it's become easy for you to understand the algorithm. So let's start with the Prim's algorithm question number one. And the question number one, let's see some little discussion on Prim's algorithm. Prim's algorithm is used to find the minimum cost spanning tree. As Kruskal's, as I've already told you, uses a greedy approach. I've already told you it's a greedy approach, that you always look for a minimum. No, you always look for a profit. You always look for a minimum cost. Prim's algorithm share a similarity of shortest path. So again, after this videos, we'll discuss a shortest path like Dijkstra. We'll discuss Bellman-Ford. If you watch this video very clearly, very attentively, you will also find it easy to understand shortest path algorithm like Dijkstra and Bellman-Ford, because this algorithm is totally based on those algorithm. Fine. Prim's algorithm, in contrast with Kruskal algorithm, treats node as a single tree and keeps on adding new nodes. In Kruskal's, what you do, you arrange edges in increasing order, but here you do not arrange, you just keep on adding the nodes. No, so let's start and solve the question. So apply the Prim's algorithm on a given graph given below. You have a graph. No, you have a graph, and now you have to apply what? You have to apply Prim's algorithm to solve it and find the minimum spanning tree. So I have making one matrix. What this matrix is all about, let me tell you. In this matrix, what am I doing is that I'm creating a queue. First of all, you can see there is a queue. Fine. And in queue, I've inserted all the vertex of this graph. How many vertex are there? 7 vertex. From 0 to 6, I've inserted all the vertex. Fine. This is what I did. Now I've inserted all the vertex. This is a part of algorithm. So I've inserted all the vertex in a queue. Now what I do, I will initialize single source. Suppose I have to start from 0. Suppose it is given that you have to start from 0 and find the minimum spanning tree. So since I have to start from 0, so 0 will become source. So I'll make node 0 as 0 and all other node as infinite, and all other node as infinite, and all other node as infinite. Okay, and all other node as infinite. Fine. So this is called initialize single source. So the first step is initialize single source. In initialize single source, what we do, we initialize source node with 0 and all other node with infinity. And second step, what we do, in second, we insert all the node of a given graph in a queue. Fine. Okay, now in the given matrix, what am I doing is that first, arrange it according to the weight. The weight of 0 is 0, and other I'm taking off nodes, not edge, and other weights are infinite. Fine. You can also say a distance of 0 is 0, and suppose other are infinite, which I have mentioned. This is called initialize single source. Now in first step, what you do, first step of this queue, you have to extract element from queue. Extract minimum queue. Which is the minimum distance? The node having 0 is having the minimum distance, so I'll extract this node. So I've already processed this node, so I'll not touch this node again. So I have ticked this node. So let me change the color of my pen now. So I have processed this node. So now what you do to the node you have taken out, now see the neighbor of those node. The neighbor of node is 0 is 5, make a double line. The neighbor of 0 is 1, make a double line. Fine. And then what you do, you see this distance and this distance, and which one is minimum, convert to that. Which is minimum, 10 or infinity? 10 is minimum. Convert it to 10. Now see which distance is minimum, 28 or infinity? 28. Now convert it to 28. Fine. So what you did, the moment you take out any node from the queue, you just find out the neighbor of that node, make a double line. Double line means you are finding parent of those node. So the current parent of node 5 is 0. The current parent of node 1 is 0 because they have identified them. Now and see the weight. See the weight of edge and the weight of node. Which one is minimum? Assign them. Fine. Okay. So I've done. So what changes took place is currently is that the weight of node 5 has become node of weight 5 has become 10, and the weight of node 1 has become 28. Fine. Again, what you do? Again, you have to find the you have to extract. In second step, you have to find extract minimum q, which is minimum. 10 is minimum, and the node is 5. So you have extracted node 5. So you have extracted node 5. Then what you do on extracting node 5? What you are doing on extracting node 5? What you are doing is that on extracting node 5, you are doing the neighbor, again the neighbor, and make it sure the moment you are extracting the second node, just you see, is there any double line? Yes, you have double line. So just make it dark. Just make it dark. By making it dark, what you are doing is that you are saying that the it is confirmed now the parent of 5 is 0. No, double line is this. You are actually finding a path. Fine. So what you do, you just make a a bold line, and after bold line, you find the parent. After you find what adjacent of node 5. So which is adjacent of node 5? 4. Now you see this 25 and infinity, which is minimum. 25 is minimum. So make a double line. Fine. Make a double line, and after that, what changes you find that 4 weight has now become what? 25. So weight 4 has become now 25, and still 28 is in queue. 28 is still in queue. You have not removed yet. 28 and 25 are still there. Now again the same step. Find what? Minimum. Extract minimum. Which is minimum? 25 or 28? No, 25 is minimum. So now you have extracted 4. So you have extracted 4. Is there any double line? Yes, there is a double line. Just dark it. Fine. So you have just darked it. So you have just darked it. Fine. And now find the adjacent of 4. So adjacent of 4 is 5 also. Can you use 5? No, because we have already processed 5. I will not do anything with 5. But other node which are adjacent to 4 are 6 and 3. Now you take care of this. So this is 24. This is infinity. So what it will become? 24. So make a double line. Just now you have identified 6, and this is 22, and this is infinity. Make it 22 and make a double line. Fine. Make a double line. So what changes you did after extracting 4? 6 has become 24, 6 has become 24, and 3 has become 22, and still 28 is in queue. Fine. Now extract minimum q, which is minimum 3. So node 3 is minimum. So you have finally extracted node 3. This is the third step. Now this is the fourth step. Fine. You have extracted the node 3. On extracting the node 3, just find out there is any double line. Yes, make it dark. So you have what you did, you make it dark. You make it dark, and what you do then, you find adjacent of 3. So adjacent of 3 is 4. You will not touch 4, that it is already processed. Adjacent of 3 is 6. Yes, you can check 6. Why? Because this weight is 18 and this weight is 24. Can you change it? Yes. Which is minimum? 18 is minimum. So I'll change it to 18 and I'll make double line from here. Now what 3 is saying to 4, that I have identified 6. I have given him a minimum weight. Now you have no relation with 6. You remove your double edge. Fine. Are you getting what I'm trying to tell you? The identifier, the final identifier of node 6 is 3 now. So there will be only double line from 3. Fine. So in order to remove the confusion, I have removed the double line from 4 to 6. Fine. Okay. Now which other node is adjacent to 3 is this 2 node. So this is 12 and this is infinity. Make it 12 and make a double line. Fine. So what changes you did after extracting 3? 6 has finally become 18. So 6 has finally become 18, and 2 has become 12. 2 has become 12, and 1 is still pending. 1 is still there. Fine. Again, extract the minimum q, which is minimum 12, and the node is 12 of 12 is 2. So you have extracted 2 node. This is the fifth step of extraction. Fine. So you have extracted node 2. Tick it. Fine. Just mark a tick. And now see, when you have extracted, is there any double line? Yes. Double line is from 3. Make it dark. So I've made it dark. No, and find the adjacent of 2. Adjacent of 2 is 3, which you have already processed. It is out of queue. You cannot take it. Fine. And what you do now, you find adjacent of 2. The adjacent of 2 is 1. So here, can you make any changes? Yes. The weight of 1 is 28, which is greater than 16, so I'll make it 16. Now node 2 will say to node 0, you have no right on node 1 because I have given a minimum weight to node 1. So this double line will be removed from this place, and it will be from this 2 to 1. Fine. Okay, so now double line is from 1. Okay, so after extraction of 2, what changes take place? This 1 has become 16 and this 6 is 18. Now extract minimum. Which is minimum? 16. The weight, which node is 16? 1. So I've extracted 1. This is the sixth step of extraction. I've extracted node 1. So I'll mark a tick on 1. Now see, is there any double line? Yes, there is a double line. So I will make a double line here over here. Fine. Okay, now you see what are adjacent to 1. Since you have extract, adjacent of 1 is 6, which is still in a queue. Adjacent of 1 is 28, which is not in a queue. You have already extracted it. Fine. Adjacent of 1 is 0. You cannot take 0 because you have only extracted it. Since 6 is already there. Now see, the final weight of 6 is 18, and what you can give? You can give it 14. Why? Because 14 is less than 18. So I'll cross it and make it 14. So the final weight of 6 is 14. So this node 1 will say to node 3, now you have no right on 6 because I have given him or her a minimum weight. So this double line will be removed and it will be attached to 1. Fine. So now what changes take place? That node 6 has finally become 14. Now extract minimum q. What minimum q is? Finally you have a last node. You will extract it. The 6 will come out. So is there any double line? Yes. Make it dark. Since there is no node to be processed now, you will not do anything. So the dark line is representing. So the dark line is representing the minimum spanning tree. Now you calculate the weight. The weight is 10. Let me change the color of my pen. Let me change the color of my pen to black. So this is 10 plus 25 is 35 plus 22 37 and 57 and 12 59 69 and 69, and this will 75 and 85 and 4 89 and 1 10 99. So MST weight is 99, and this is the final shape. So what you will have to do, you have to make a graph again, and you will include only the dark edges. Fine. Since I'm not having a space, so I'm not using it. So this is how we are solving. What? Minimum spanning tree using what? Prim's algorithm. Why we are studying this? Because this is another method of finding minimum spanning tree, and it has similarity with shortest path weight. So I request you to kindly watch it. Do not ignore it, because you will find Dijkstra and Bellman-Ford very easy. We'll use the same method, same matrix, extract minimum q, insert in q, initialize single source. We'll use all same things in Dijkstra and Bellman-Ford. So at last, I'll give you one more question for a homework. So you have a question for a homework. You have to comment me what was your minimum weight after solving this using prims. Fine. So this is homework. This is homework for all my viewers, those who are watching right now. This is homework, and please comment that what is the weight MST, what is the weight of this when you will construct MST from this given graph.